Hello everyone and welcome to a shorter video which was inspired by my friend who was studying for her math exam and she ran into a problem like this. Exactly this one. I mean, she knows that I'm a Vtuber, sort of. So I sent her my videos in which I explained the probabilities and combinatorics, two of them, and she looked over them and said they were quite handy and because she understood what I was explaining and then it could come in handy during her exam. So I was like, you know what if I take this example and I show you how to solve it using just the knowledge that we got through my two lectures. We have 3 boxes with balls. The first box has 4 white and 5 black balls. Second box has 3 white and 9 black. Third box has 2 white and 3 black. The probability of picking a box is proportional to the number of the balls in the box. And then after we select that box, we take 2 balls from it. So what is the probability of picking 2 white balls? Let's break the problem down, as it is quite of a big one and objectively on the harder side of the problems as it is a university level problem, but we can solve it. First, let's write out what we know. I marked the information with bold and underlined. We know that we have 3 boxes. We know that each has a different amount of balls and that there are only white and black balls as much as the information has been given to us. We also know that we pick a box and the probability of each box being picked is proportional to the amount of balls in the box. So the more balls it has, the more likely it is to be picked. This will come in handy a bit later, but it's important that we know this down. Then we take 2 balls from that box. So what is the probability of it being 2 white balls? So for that we need to know the probability of 2 white balls per box being picked. So for all possible scenarios. For all possible boxes we can choose from, and then since picking the box and taking the ball out are basically in a sequence events, we multiply the probability because you have to pick the first box to apply the probability of getting 2 white balls of the first box, you know, like kind of like throwing a die, and if it lands above 5 you roll again. So like that. I guess that's how I would explain it. Basically, you have to pick the box first for the probability of 2 white balls being taken out to come into effect. So all of this is important to know. And yes. So here I basically wrote the probability of picking a box is proportional. We remember this symbol. And then that if we take the nth box, we have to know the probability of 2 white balls being picked in that nth box. I think this is all we need, so let's see the formula. For this formula, I assume that we have our sample space and it only has 3 elementary outcomes, or 3 events that can happen, to be more precise. The first event is to pick a first box. Second event is to pick the second box, and third event is to pick the third box. They have no overlap. I should maybe draw this. So we have our sample space. We have our box 1 event, box 2 event, and box 3 event. So here, the first term with 2 factors represents the probability of picking 2 white balls in the first box. So the first part, if they were all equally likely to be picked, we would have 1/3. Each would bring 1/3 of a weight. So if we have 3 boxes and we choose at random, each has a chance of 0.3333 periodically repeating to be picked. However, they are more likely to be picked if they have more balls, so we replace that 1/3 with this probability. We know that these probabilities of the boxes being picked will add up to 1 because we only have 3 choices and we have to choose one of them. So these 3 will add up to 1. And they're not equal, that's why I noted them down separately. The second factor is weirdly labeled of NVWB. It basically means the probability of picking 2 white balls in the nth box. So after I broke this down, it's a very simple part. Even if we just took it at face value, I can, like this. This would be the probability of picking box number 1. And then inside that box picking 2 white balls out of 4 white and 5 black. Basically, this is the formula. It makes sense. If you don't understand it, please ask in the comments because I'll gladly explain it. Now let's try to see what each of these factors would look like as mathematically written. So we can generalize them into probability of the box being picked and probability of 2 white balls drawn from the box, as I explained. So for picking the box, the probability of it, as specified in the exercise and underlined, is the numbers of balls in the box divided by all the balls in all the boxes. Because, well, they have to add up to 1, and it's proportional to the number of balls in the box. So technically you could multiply it, each of these probabilities of 2 white balls being picked with the number of balls in the box, and then divide all of them with the number of all the balls. Kinda could work, but let's see how I decide to solve it. As for picking 2 white balls, then we need to know what is asked of us, like we did in the combinatorics last lecture. So we take a ball from the set, the ball doesn't return, and then we take another ball. The order of them doesn't matter as long as they're both white. So in other words, if we label them, there will be no difference between drawing a white ball number 1 and white ball number 2 in this order. Then it would be to draw a white ball number 3 and a white ball number 2. So we're looking for combinatorics. When there are combinatorics, we use the binomial coefficient, so the bracket division resembling thingy without the division line. And don't worry, I'll break them open in a bit, we'll just write it down. So on top, we have the binomial coefficient of number of all the white balls in the box. And underneath that, we have 2, showing that we're looking for the number of combinations of 2 white balls. And in the denominator of the fraction of probability, we have a binomial coefficient in which the top part represents the number of all the balls in the box, which I have summed up on the right. And underneath is 2 because we're looking at all the possible combinations of 2 balls per box. So we can have a distribution of what percentage do the combinations, so what percentage do the number of all combinations of white balls represent against the number of all the possible combinations of all the balls in the box. That's overcomplicated, but if you look back at the probability or combinatorics, you'll see this again just a lot shorter. So this fraction is essentially giving us the ratio of all combinations of only white balls compared to the number of all the combinations of all the balls. Makes sense. This represents the probability of picking 2 white balls out of all, as we hopefully remember, right? So we have 26 balls in total, so I wrote the sums of balls per individual box next to them in the description on the task at hand. And then I underline them with the corresponding colors because I forgot that before. If all is clear, let's insert them into the formula and fill in the values to solve. If not, skip back or comment down below and ask me if anything is unclear, because I will gladly come and help you. So first I will insert the probability of picking the individual box, and after that we insert the probability of picking white balls from each box. So I inserted the number of balls in the box divided by number of all balls, so 9 over 26 for orange, 12 over 26 for purple, and 5 over 26 for green. Perfect. Now we see that in the first box we have 4 white balls over 2 divided by 9 balls over 2. And this is our fraction for the probability of picking 2 white balls in the box number 1. Now we do the same for purple and green part, so the second and third box. And we get this mess. Now, if I will break the coefficients into fractions to help us solve it. So we remember that the symbol, binomial symbol, means that the n over k is n factorial divided by k factorial times n minus k factorial. So we can rewrite this as a fraction where the bottom 2 numbers without factorials add up together into the top one. So here we break the 4 into 2 and 2 because we had 2 underneath. There's always going to be one factor that's going to be 2 factorial, and then you just subtract from the top part and you get the remainder. So here we know that 9 was on top and 2 is definitely on the bottom, like here. And then 9 minus 2 is 7, so we do this the same like this. This is basically combinatorics again, so I'm not gonna explain it for every step, but we do this for purple and green as well. Now, I will go ahead and write out the factorials in the long form and cancel out what needs to be cancelled out to simplify them all. So basically after all is crossed, we see that 2 factorial gets cancelled, 7 factorial gets cancelled, 2 factorial, 10 factorial, 2 factorial, 3 factorial, and then we just have 4 times 3 divided by 2, and stuff like that. We just simplify it all. So we know that factorial is just all the natural numbers from 1 to itself multiplied together, so it helped big time simplifying it all. So we got this. After that, we can multiply and divide again to get the second part like this. Now we're gonna simplify across with the left fraction. So for instance, here we can divide 9 and 6 with 3. So we get 3 here and 2 here. And we do the same for all of them. So like this. Now I will multiply the top parts and the bottom parts together to get a sum of 3 fractions, like this. Now that we have 3 terms that we need to add together for the overall probability that the question asks of us, we can go ahead and solve it, right? So let's have them all set to the common denominator. So I will multiply the orange and the green part with 143 and the purple part with 52, so we can set them to the common denominator. So I multiplied it like this, and I just rewrite this as probability. So I put this all into the same division line because they have the same denominator, and then I write this as in the form of the answer, so probability of picking 2 white balls for the answer. Now we multiply the top parts to get like this. We can add them up into 728 divided by the common denominator. And let's get ahead and simplify it. We would eventually find out that 728 is divisible by 52, so you would go step by step dividing by 2, then another 2, etc. And the result of this division is 14, so 14 times 52 is 728, which gives us 14 divided by 143, which is roughly 9.79%, which is the answer to the question. Hopefully you were able to follow along, or at least see that just by using the basic probability knowledge that I taught, well, 2 times ago and 3 times ago, you can solve some slightly more complex problems if you break them down enough. So this was it for this video. It's shorter, although still quite long. Thank you all for tuning in. I wish you best of luck with all your mathematical journeys this year. And yeah, if you have any questions, comment down below and join the Discord if you need more help. And I'll see you all on our next quest. Bye!